By the time it opens. Yeah. See, when you talk about quick sort, how it is, we need to have a comparison between merge sort and quick sort. Okay. So merge sort, what happens is, in your case, like we were dividing the main array into two halves. Okay, equally into left half and then right half. And then actual things are happening in the combined step. Okay, so in the case of merge sort, what happens is the divide step does hardly anything, and all the real things are happening in the combined step in the case of merge sort. Okay, so you can say that both merge sort and see few similarities are there between. Before I get into the quick sort algorithm, you need to have some analysis about this. Okay, so both merge sort and quick sort are based on divide and conquer algorithm design technique, right? So but what happens, and both are recursive algorithms. Okay, both are, first thing, similarities we will talk about. Merge sort and quick sort, they are based on divide and conquer algorithm, right? They are based on divide and conquer algorithm design technique, right? And then both, it is a recursive algorithm. Both are recursive algorithm. And when you talk about merge sort, what happens is the divide step does hardly anything, and all the real work happens in the combined step, right? Whereas quick sort is just the opposite, and the main things are happening in the divide step itself. Actually, if you see in the combined step, nothing is happening. Yeah, in the divide step only, the array will be in a sorted order. Okay, so quick sort is just the opposite of the merge sort, where the real work happens in the divide step. Okay, you know that in the divide and conquer algorithm design technique, we have three different steps. So what are the three different steps we have is, we have something called, yeah, we have something called divide step. Then we have something called conquer step, combine conquer, and I mean we are dividing the problem into sub problems, and then we solve the sub problems. Then we get the solution by solution to the original problem by combining the solution of the sub problems. So that is the idea behind divide and conquer. Correct. So so we have something called divide, conquer, and combine. There are three important steps in divide and conquer. Now, if you talk about this divide step in merge sort as well as quick sort, what I want to tell you here is, in the case of merge sort, which you have already seen, we have been dividing until we reach a base case. I think you are able to visualize merge sort. I already taught you. So you are able to visualize merge sort. So if I have 8 elements, I keep dividing into 4 elements. 4 elements are divided into 2 elements. 2 elements are divided into 1 element. So in the division, actually, if you can visualize, nothing is happening. But the main things are happening. The real things are happening. The sorting is happening in the combined step in the case of merge sort. Whereas in the quick sort, what happens? It is just the opposite of the merge sort, where the main things are happening in the divide step itself. So how it happens, I'm going to talk about, no problem. And the combined step does absolutely nothing, because when it comes to the combined step, in the divide only, the elements are going to be in the sorted order. So that is the main important difference of merge sort and quick sort. That is the first difference. Okay, so first we saw, because these things, no, theoretically also you should have a strong base before getting into the algorithm, right? So the similarities, two similarities. One is both merge sort and quick sort are based on divide and conquer algorithm. The second similarity is both uses a recursive algorithm. These are similarities. This differences is whatever I said now, how the divide and combine step happens. The second difference is about the time complexity part. Okay, so worst case time complexity of quick sort is as bad as selection sort and insertion sort, that is big O of n square. Whereas average case time complexity and the best case time complexity is same as merge sort. So what is the time complexity of merge sort we got in all the cases? We got big O of n log n. So how n log n came? I have explained to you in the last class, right? So in the merge sort time complexity, if you see all the cases, best case, average case, and worst case, the time complexity is theta of n log n, theta of n log n, right? So whereas for the quick sort, we will get worst case time complexity alone as big of n square, whereas average case and best case time complexity will be same as merge sort. Okay, and this is the second difference. Third difference is quicksort is an in-place algorithm. I'll just come to later what is in place and it is not an in-place algorithm. Quicksort is an in-place algorithm, whereas merge sort is not a in-place algorithm. So these are the main differences. Then we will get into the algorithm. Okay, we will get into the algorithm. Okay, just before taking an example, let us understand in a nutshell, I mean extensively, how it is going to work. Okay, so if we have array, if we have an array of array is containing elements from P to R, think that it is your leftmost index is P and the rightmost index is R, like that. Okay, so what we will do, what we are going to do is we have to divide. First step is divide. Quicksort uses divide and conquer, and we need to so the arrays containing some elements, and you know that array index starts from 0, and so your array is 0 to n minus 1. So all of you are aware of this. Okay, so the first step is you have to divide. You have to divide by choosing any element in the subarray. So what is this quicksort is going to do is we are going to choose one element as a pivot element. Okay, you are going to choose one element as a pivot element. This pivot element can be chosen. So normally we choose the leftmost element as a pivot element. Okay, so the element, the leftmost element can be chosen as a pivot element. And we also, it's not necessary that always the leftmost element has to be chosen as a pivot element. So there is a, again, which element has to be chosen as a pivot element. So it's also, you're not able to see the screen, no?
Ma'am, you're already in the meeting. We can see your screen.
1 second. You're able to see the screen, huh? But thing is, suddenly that where I was having, no? Okay, I want to take something. Okay, we'll open on Word document and we'll do. Okay, so basically the first step is divide. Okay, so in the first step what happens is, okay, so we need to choose the element. Okay, choose the pivot element. Suppose I've been given some elements. We will take some elements. Okay, I'm just giving, I'm taking some sample elements. 4, 3, 6, 9, 2, 4. No need to have a repetition for now. Okay, that is not there. 8, then 6 is there already. 3. Have 1. How many elements are there? 1, 2, 3, 4, 5, 6, 7. So we'll keep. Okay, so 4 plus 4, 8 we have right now. Okay, now what is the first step in quicksort is we need to choose the element called pivot element. Okay, so that is what I was talking about. The first step is we need to choose the pivot element. So in our case, I'm going to choose the leftmost element as a pivot element. That means, one second. Okay, let it be like this so that it will be little more clarity is there. So I'm going to choose this element as the pivot element. Okay, so all of you are able to see the screen, no? What I am talking? Yes. Okay, fine. Now we need to choose the element as a pivot element. So now I was talking about choosing the pivot element. The first step is we need to choose the pivot element. Okay, so this element could be the leftmost element. Okay, leftmost element, and then start doing some manipulation. What kind of manipulation I will tell you. Now you may ask me a question that whether this leftmost element only has to be chosen as a pivot element. Not necessary. It can be the middle element, it can be the last element. Next question means talking about the pivot element itself, right? So it could be the first element, or it could be the mid element, or it could be the last element can be chosen as a pivot element. No problem. So I will show you, but there is some purpose for choosing the leftmost element as a pivot element, but it is not compulsory that only the leftmost element has to be chosen. So, okay, so leftmost element, mid element, or the rightmost element, or we can choose the smallest element, the larger element. What are the different cases we have to think about that. So what happens here is when we choose after choosing the pivot element, what we have to do, we need to rearrange the element. Okay, first step is first, still I am in the first step only. First step, I am calling that first step as divide. Okay, I am calling that first step as divide. Now in divide step only, I have to choose the pivot element. I have to choose a pivot element. So now we need to rearrange the element. Next is, in that we have, what we have to do, we have to, in the divide step only, what we have to do, slowly I'll tell you. So we have to rearrange the element. Okay, rearranging the element. So how we are rearranging the elements? Okay, so we think that suppose the array. Okay, so what array I am having? I'm going to have think that I'm going to have a array. So what is the array is? Think that array is A. Okay, I'm calling array as A. And the elements in the array is P to R. Something like that. Okay, so this is my array. This is my array. Some other color will give. Okay, this is my array. Just quickly I will tell you. Okay, so this is my array A of P to R. Okay, so the leftmost element is P and rightmost element is R. Think like that. Okay, now I have chosen the first element. So this is A of P. A of P is nothing but 4. A of R is nothing but 5. In my case, A of P is nothing but 4. A of R is nothing but 5. Okay, now I have chosen this P, this as my pivot element. Okay, that is a 4 as a pivot element. Now we need to rearrange the elements such that, okay, all elements towards the left of the pivot element should be less than the pivot element, and the elements towards the right are going to be greater than the pivot element. Okay, so so what we have to do, to get that, all right? So in the divide step itself, we are going to do some manipulation such that we need to rearrange the elements. We need to rearrange the elements in the array so that, how to rearrange? I'm just writing all the elements towards left of the pivot. Okay, towards left of the left of the pivot are smaller. Okay, and the right are greater than the pivot. Okay, so we need to do that step. Okay, so we need to do that. Okay, this is your first step itself, not the second step. This is your first divide step. Next, what is that we have to do? Okay, how I am going to how I am going to rearrange the elements, I am going to tell you with the algorithm. Okay, now what is my second step? What is my second step? Okay, so here and there formatting and all you don't consider. Now next is conquer. So what is this conquer step we are doing is, we have to recursively sort the left subarray and the right subarray. Okay, so in the conquer step what we are doing, so divide in conquer step only, what we are doing is, we have to, how do we divide the array? Anyone can tell how can we divide the array into two subarrays? Suppose this original array, I'm calling it as A of P to R. Okay, so how do I divide this array into two subarrays? So I can just conquer. In the conquer step, what we are going to do, we have to recursively sort the two subarrays. Okay, what are the two subarrays we will have? I'll just tell you quickly. So one array will be A of, okay, P2 Q minus 1. Okay, so Q minus 1 is the before middle element. Okay, so array should be kept like this. And what is the next array? We will have array of, so when I have the Q as a mid element, what now subarrays I'm calling it as A of P to Q minus 1. So what should be this array? Okay, instead of writing array name only I should give. Okay, I'll give us A because our array name is A. Okay, so I want one of you to tell what is the next subarray. Let it be an interactive fast. What will be the next array? This is left. P is the leftmost element. Yes.
Q to R.
Q to R. Very good. Okay, so we have to, in the conquest step, we have to recursively sort the two subarrays such that, so once you sort like that, then you will get the arrangement, like all the elements towards the left are smaller than the pivot and the elements towards the right are greater than the pivots. Okay, now what is my third step? This is, I'm just writing like an English like instruction, still I have not gone to the algorithm. So now next step is combine. Okay, we have three things, no? One is divide, conquer, and combine. So in the combine step, what we are doing? In the combine step, we are doing nothing. So in the conquest step itself, the array will be in a sorted order. Okay, so in the conquest step itself, when it is recursively sorting, right? Because the elements, once I get a scenario where the elements towards the left of the pivot is smaller than the pivot element and the elements towards the right are greater than the pivot element, then students, you have to join back. Okay, after 10 minutes you have to join back. I have taken more time only. You can just get back Once this meeting is over, after 10 minutes, you have to join back. Okay. Now, in the combined step, so in a nutshell, if you see, the first step is divide, second is conquer, third is combine. So what is combined step doing? It's actually doing nothing. Okay, so only I told you, in the case of it's doing nothing means don't write in the exam like this, doing nothing. But for you to generally understand, I'm just writing like this. But actually, if you speak, it is doing nothing, because in the merge sort, if you see, in the combined step, in the merge step only, actually the sorting, internal sorting is happening. But it is not the case of quick sort. Okay, so now how are we going to do this? How are we going to do this? All these three steps, how are we going to do this? Okay, so we will have there are two algorithms here. Okay, there are two algorithms. One is quick sort algorithm, where we will recursively call this quick sort algorithm. Inside quick sort only we will call. So one algorithm is quick sort. Okay, so like in merge sort, we had merge sort as well as merge. Here quick sort and one more algorithm called partition will be there. Okay, so how do we partition? So there is one more algorithm called partition. Okay, so in quick sort algorithm is there, and then we have partition algorithm is there. Okay, so first I will write the quick sort algorithm. Okay, so in the quick sort algorithm, what we are doing? So okay, so first I will I'll write for you quickly the quick sort algorithm. So any algorithm should start with what? Algorithm keyword. Okay, so algorithm keyword. Okay, so next to what I should write? What is the name of the algorithm? What is it? I'm writing about algorithm quick sort. So what is the name of the algorithm? Anybody? Quick sort. Can I write quick sort? What is the parameter we are passing? Anyone passed? What is the parameter we have?
Array, ma'am.
Array. Okay, very good. So the array name is A. I'm taking A as my array. So inside the quick sort algorithm, we are passing array. So this array is going to have either you can just say it is now here P and R I have written. For our understanding left and right, it is better we write leftmost element and rightmost. So according to your textbook also, it is better and meaningful notation also. Okay, so we'll say left and right we'll write. Okay, no problem. Anything we can write, no problem. Okay, so inside this what we are doing, okay, in the algorithm what we are doing. Now what we have to do is we need to check if left is less than right. If left is less than right. See, when I check like this, what are we checking basically? See, last class I told you that there will be something called base case for any algorithm and general case. In merge sort, what is base case? Anybody? Did I tell in the class, your class, what is base case? When do you do? When you arrive at a base case in merge sort? Merge sort already I've explained to you. No, same way it is applicable for quick sort also. What is base case? Anyone in the class? Fast. What is base case? In sorting, generally in sorting, what is base case? What is general case? Anyone? I'm not calling anybody. Just 5 more minutes is there. Okay, let me only tell. Now, what is base case is if I have only one element, if I have 0 or 1 element, there is no requirement for me to sort, right? So that now in the merge sort also, what we are doing, we are dividing the array into two halves, left half, right half. This left half will be divided into two halves. Again, we keep on dividing until we get only one element. So when I say I have reached one element, that is a base case. Okay, further I cannot divide in the case of merge sort. Now, once I'm not able to divide, what I will do, I will start merging. So once I have reached a base case, I will start merging, and then we keep merging, and then finally we get a sorted array, right? So what is base cases? Base case is a scenario where there is no requirement of sorting. We have reached a very smaller problem instance. We need not further divide the problem instance. The same thing is applicable here also, quick sort also, right? So now if there is one element, we are not worrying about sorting. But now, if obviously this condition will be true, if left is less than right. What is my left? Where is my elements? Here it is. Okay. Now left. Now we will write the position here. Okay. Now your array index starts from 0. Right. So what is 4 pointing to? It is a of 0. Okay. This is a of 0. 1, 2, 3, 4, 5, 6, 7. Okay, so n minus 1, the size is n. So this is your, okay, I'll write like this, a of 7. Okay, that is nothing but your array size is, what is the size of the array? N is 8. Okay, so I have totally 4 plus 4, 8 elements. So the size of the array is n is 8, and array index starts from 0. So 0 to n minus 1. So what is 0? 0 is left. So a of left to right. When you say left is the leftmost index, not the element. Okay, please understand, these are all very minute things you should be knowing. So elements are given in a random order, and we are going to do the sorting using quicksort. So that is the problem statement. Now 0, left will be pointing to 0, right will be pointing to which, what is the index, ma? In our case, what is the index? Can anyone tell? What is right pointing to? Yes, fast. What is right pointing to? 7. Right is pointing to 7. Very good. Now 0 is obviously less than 7. Am I audible? Hello?
Yes, ma'am.
Okay. Now, obviously, this condition is true. If left is less than right, what I am supposed to do? Okay. So I have to partition the array. So how do I partition? So I'm just writing the, so partition. Partition A of left to right. Okay, so this such that, okay, this is actually a comment statement. So we will write only the main thing. Okay, so comment statement we will not write now. Okay, we will start writing the main algorithm statement itself. Okay, so to sort recursively the left part of the array, what we have to write? Quick sort of, what is the name of the array we have? A. A is left to p minus 1. Okay, somebody was telling, I just wanted to, this, no, here, there is an element called q. Okay, so that q here, somebody was telling like a of p to